Hello and welcome to the presentation here. In the previous session, we learned the forward bias characteristics of Pn junction. And in this video, we will see the reverse bias characteristics of the Pn junction. To make the junction Pn junction reverse biased, anode of the diode has to be connected to the negative terminal and cathode of the diode has to be connected to the positive terminal of the external battery as shown in the figure. The behavior of diode with the application of reverse voltage across anode and cathode and the reverse current which is possibly flowing in this diode is observed by plotting the two variations in the negative two-dimensional axis here. When the external voltage is increased from the battery, the width of this depletion layer is increased. The concentration of ions also increases, and this will result in the increase of barrier potential. This increased barrier potential at the junction will not allow any of the majority charge carriers from either the P region or the N region to cross this junction, and there will be no current resulting or no current flowing through this diode, and the diode is said to be in the off condition. With the P region connected to the negative terminal of the battery, all the holes which are positively charged will be attracted and moving away from the junction. This is the reason for creating a high negative ions in this P region near the junction. Similarly, as the N region is connected to the positive terminal of the external battery, free electrons are attracted away from the junction, creating the increase in positive ions concentration near the junction. Due to this, the barrier potential will be increased. However, the minority charge carriers present in both P and N regions will be moving in the opposite direction and they will cross the junction, creating very little current in the order of microamperes only. As you can see in the characteristics plot, a small current starts flowing, which is indicated by the red line in the characteristic plot, which will be in the range of microamperes only. If the external battery voltage is still increased to the higher value, the same effects are again magnified. The depletion region is still widened, increasing the strength of these positive and negative ions. Near the junction, the barrier potential is increased to the next higher value, but the flow of minority charge carriers will continue and remain the same, creating the same level of the small microampere current, which we called as the reverse saturation current through this diode. If the external battery voltage still raised to the next higher voltages, the barrier region voltage will be still increased, increasing the width of this depletion region. And the same reverse saturation current will be flowing. When the application of the external battery voltage reaches to such a high value, due to which the high electric field influences the electrons of these semiconductor atoms to discharge themselves and cross the junction, creating a sudden huge reverse current. and this point at which this huge reverse current starts flowing is called as the reverse breakdown voltage. Reverse breakdown point and the corresponding voltage is called as reverse breakdown voltage VBR. You can observe that at this point of application of the voltage VBR, the voltage across the anode and cathode is almost maintained constant, but there will be a large rise in this reverse current as seen by the red line in the characteristic plot. This region before the reach of this reverse breakover point is called as the reverse saturation current region. Once the reverse breakdown voltage is applied to this diode, it starts conducting heavy current, and this region is called as the reverse breakdown region. If the diode is maintained to work under this particular region for the longer duration, it may reach irreversible damage of itself, means the diode will be destroyed permanently. That is why the diode is not allowed to work after this reverse breakover voltage point. In our next video, we will be seeing the working of another beautiful invention of the semiconductor, which is called as the Zener diode, which is deliberately heavily doped and properly designed to work only in this reverse breakdown region. We will see the application and the characteristics of that Zener diode in our next video. To summarize the reverse biasing of this PN junction, whenever the anode of the diode is connected to the negative terminal of the external battery and the cathode is connected to the positive terminal of the external battery, the diode is said to be reverse biased. And under reverse biased condition, there will be no flow of current through this diode, and the diode is said to be in the off condition. This is how the characteristic of the reverse biased PN junction can be explained. We'll see in the next video.